in this video we're going to look at slant or oblique asymptotes, and they happen when the degree in rational functions when the degree of the numerator is larger than the degree of the denominator. You see right here the degree is 3 in the numerator, degree of the denominator is 2, so we have the degree of the numerator is larger. So we don't have an horizontal asymptote as the limit as x goes to positive or negative infinity is not f but g of x is going to be, in this particular case, going to be positive infinity, but it could also be negative infinity. So when you have this, you can still obtain some important information about the graph, and that is that the function will behave like in this picture right here. You are going to have the function getting closer and closer to a particular line, like in this case, as x starts growing. So the line, this oblique or slant line is going to play the role of the horizontal line that we had in the previous video. So the graph of the function as x grows will get arbitrarily close to this line. So to determine it, there is an easy way to do it. Let me try to leave everything on the screen. So let's leave this function here. So what you're going to do, you can do a long division to rewrite this function g of x. So you're going to write just like you divide when you were a kid, except now we're going to use variables. So we're just going to do the long division algorithm. So you have to ask how many x squareds can I fit in x cubed? Well, x many of them. When you multiply times x, you get x cubed plus 2x squared, and then you're going to subtract this off. X cubed minus x cubed goes away, and then you get 0x squared minus 2x squared is going to be minus or negative 2x squared, and then plus 1. So I just lowered this 1 here. And now I ask, how many x squareds can I fit in negative 2x squared? Well, just negative 2 of them. And I put negative 2x squared. Multiply negative 2 times 2x is going to be minus 4x. And then I'm going to subtract it off. So negative 2x squared minus negative 2x squared goes away. And then I have 0x minus negative. So it becomes 0 plus 4x, so it's just 4x plus 1. So what this is telling me is that I can rewrite g of x as, instead of writing it as this quotient, I can write it as this, instead of writing it as this fraction, I'm going to write it as the quotient of the long division, x minus 2, plus, and then you copy your remainder divided by remainder divided by the divisor, which is x squared plus 2x. And I'm just using this division to rewrite my expression for g. So notice that now as x goes to infinity, whether it's positive or negative infinity, this term right here is going to go to 0. So this limit will be the same as the limit as x goes to infinity of x minus 2. Now this obviously goes to positive infinity, but what this expression tells you is that this term will go away, so it's going to get arbitrarily small, and the function is going to get arbitrarily close to this part right here, this x minus 2. So your slant asymptote or oblique asymptote is just that line y equals x minus 2, which is what I have right here. If you see this line, it has slope 1, and then you have right there negative 2. Okay, that's your intercept. So that is how you calculate your oblique or slant asymptote. So that's that. All you have to do is practice your long division. If you have problems or you have questions how to do this, then join the conference on Thursday. We're gonna do a few of this just to make sure everybody is on the same page. Alright, that's it for this problem. I hope everything makes sense. If not, just make sure to ask your questions. Thank you so much for watching.